Oh, hey, sports fans. Learning targets for 1-3. This section is about creating and using histograms. So I can make histograms. That'll be good if you can actually do that. And use them to show the spread of the data. So different things you can use, like the spread of the data. We could also talk about shape, or clusters, or, so I guess we could add that, shape, clusters, or skewness. There's a cool word for you to learn, skewness. I understand, second thing I want you to know, I understand the difference between frequency and relative frequency. Those are the things that you really need to understand from this section. This isn't going to be a terribly long video, which I'm sure is disappointing many of you at this point. Okay. Whoops. Where am I going? Creating histograms and using histograms. Well, so you have a whole bunch of data, but you don't know how it's distributed. A distribution is a function whose values are frequencies, relative frequencies, or probabilities. But here's the key point. They are mutually exclusive events. And the key word right there, or phrase that helps you also interpret that, is non-overlapping. The number 7 cannot be in two different categories. It can only be in one category. So that's what they're getting at right there, TV fans out there. So in a histogram, we decide what our intervals are going to be, typically 6 to 10 intervals. Okay, you don't really want to get millions of intervals. You do not want to get just a couple. You would like to have between 6 and 10. So you do have to take your range and kind of split it up based on what you think. If it makes sense to go by 50s or by hundreds or by 20s or by 5s or whatever, you decide what it makes sense. I mean, maybe you have to go by thousands. It's just all up to you. You make the decision on what makes sense. Now, a frequency, let's see if I can zoom in a little bit more here. A frequency histogram displays the number of values. Like, let's suppose there are 10 different numbers that fall in a category. And how is that different from a relative frequency? Well, a relative frequency shows percentages. Percentages. So how do you change the number that fit into a category into percentages? Well, you would just divide by the total number of values in that particular table. So here we have two different histograms. You can see that the number of representatives from a state, the categories along the bottom are all the same. You will also notice that the left side of this interval is closed. And the right side is open. So for instance, well, you can't even see that, can you? Closed and open. So for instance, if the number is 0, it fits in this bar. But if it's 5, it will not fit in this bar, because 5 is not included in this interval. So 5 would go to the next interval, because it is included in that. So if something was an actual number of 5, it would fit in the next category. Now, how do you change this into this? You have to divide by the total. So the number of representatives in Congress, you would take each bar and divide by that. So there'd be, well, so in this case there's 50 states, so you're going to divide everything by 50. And that will change them into percentages. And so this is called a frequency. side. Duh. And this is a relative frequency. Let's see, I think we can go to the next page. I don't think we need to talk about a whole bunch of stuff there. Okay, jumping down to analyzing histograms. Histograms help you to see features of the data set that are hard to capture from a table, obviously. So, for instance, is the data stacked up on one side or the other? Is the data, what we call skewed means it's pushed to one side and has a tail. Okay, as you can see, this is kind of stacked up on that side of the graph, but the tail, which would be this part, points in the direction of the skewness. So this would be called left skewed. Now, to be symmetric, would be something like this. Okay, this is symmetric. Okay, it does not have a tail. It has a middle value. This is very symmetric. Okay, symmetric means you can cut it in half and it looks the same on both sides. Kind of like my wife's wedding ring, because I wanted to make sure that it was symmetric, not only horizontally, but also vertically. I know, I'm crazy cool like that. This particular picture right here is skewed right, because the tail points in the direction of the skewedness. You will also notice there are gaps in the data, and you can see that in the chart. My goodness, my computer's making all kinds of noise. So the population pyramids are an example of a double histogram, right, where they put the intervals in the middle. I won't be asking you to draw these out, do a double histogram or something like that, but to analyze them, you can take a look at it and see any trends. Obviously, they're comparing males and females, 1980, and then they make an estimation about what they think will happen in the year 2020. Okay, so I don't know why these demographers, which is what they're called, made this estimation. They must have some, information which leads them to believe that this is going to be the case. But that's the prediction comes from the U.S. Census Bureau. And I think that's pretty much it on our video for today, and you can get started on the homework.